I hope no one's a full stack developer. I'm probably going to make a joke about that later. But yeah, so we're a pretty ops friendly crowd. Anybody dev? Anybody a full-time dev? I know. Oh, I know. We don't even know why you're up here.
Yeah, I don't either.
Yeah, it's weird. Like, you develop ops.
Right.
Like we let you in. You have an honorary.
I never do ops though.
Yeah, you have an honorary degree. Yeah. It's fine. All right, so pretty ops friendly house. Good, as it should be. All right, so let's go ahead and get going. We're about 3 minutes out. We're 4 minutes after, and there's a mountain of we're going to be hitting you with the fire hose like we always do. So we're going to go ahead and get rolling while the last folks straggle in. I'm Jamie Duncan. That's my email address, cloudguy@redhat.com. It took a director level approval to get cloudguy@redhat.com. It's one of my, like, in my time at Red Hat, that's one of my major accomplishments, getting that email address. That's a pretty low bar when you stop and think about it. It's not on your resume, got cool email address. That's also my Twitter handle. Lots of tweets about containers and really cloudy things and toddlers and chickens. I don't know how all that works out, but that's pretty much what it is. And you, sir?
I'm Dan Walsh. I do coloring books, and my Twitter handle is RHatDan, which means I can never leave Red Hat, so they own me. But yeah, I lead the container team at Red Hat, so I do everything underneath Kubernetes. So it's kind of weird that I'm up here doing this since I don't really work above Kubernetes.
It is, I think, yeah.
But obviously I'm big into security, so there's a section on this we're going to talk about how I believe you should run your containers in production, so we'll talk about that.
Yeah, and I don't know, I don't think it's weird. Like, Kubernetes is pretty useless if you don't have a container to run in it. You know,
I actually work for OpenShift now. So.
Is it? Like
3 months ago I started working for OpenShift.
You got reorganized? A little bit about me. I do this for every presentation. That's my daughter, Elizabeth. She's my good luck charm. She's the cutest thing ever. That's not negotiable. On the other side of that couch, there was a crying 3-year-old that she had just wailed on. She took a sword, beat up a 3-year-old, then took his sword, and then rolled around the corner like Conan. I don't know what I'm in for, but I'm a little afraid. She's 20 months old, beat up a 3-year-old, and took his sword. I've been at Red Hat about 6.5 years. I've been working with government customers that entire time. I've worked with the support. I started out in the support and engineering world, and I've actually been working with our government sales teams for the past 2.5 years, plus or minus. So I'm the geek the sales guys call in when they need some help. Little shameless plug. We just released this book, OpenShift in Action. I have one copy left in my bag over there. So if someone asks an awesome question, I have a free copy of a book. If not, I'll give it to Dan. Dan actually makes a cameo appearance in Chapter 7. I have a very unflattering picture of him in a screenshot. And then there's a little call out that says, "Who is Dan Walsh?" And we get to explain him. So he's got a cameo in here. So yeah, a little bit of a shameless plug. Dan?
Obviously, he picked the picture of me.
He's the GOAT, greatest of all time. He's the GOAT.
So my team, as I said, I work on container team. We have new products. If you got the coloring book, we talk about them there. If you saw my talk yesterday, projects called Cryo, Podman, and Scopio, which are all tools for sort of taking apart Docker into its core components and then trying to build simpler tools that you can specialize in doing individual tasks. Then I also invented a tool called Builder. And as Jamie pointed out, I also work on Docker and
SE Linux.
And SE Linux. And I do coloring books. I've been a Red Hat for this August will be 17 years, so I've been around for a long time.
That's amazing. So we're 25 years old.
Good.
So you were employee number what?
Well, when I started, it was 400 employees. So I don't know exactly.
Like I was around. I think it was in 5,800 or so.
Last time I looked, I think there's 40 people at Red Hat longer than I am.
Really?
At this point, yeah.
That's nuts. That's wild. That's pretty cool. All right, so today's task, we did this talk last year, same title, OpenShift for Operations. And really what I did for the last year's version was I took the discussions that I've been having with our customers, and I put them in a slide deck. And really just, I did the same thing. We did the same thing this year, and we put a little extra spin on it. So a year ago, the ops world was really still trying to come to grasp with what is a container, what is this new thing, what kind of new artifacts am I going to have to deal with because my developers want me to give them a container platform. And that's really what we focused on. So it was very nuts and bolts. It was, we walked through, we're going to do a little bit of what we did last year, kind of walk through how OpenShift creates containers and who's responsible for what. But last year it was very nuts and bolts. Like we were down like in calling out kernel parameters to figure out which interfaces were attached to what inside containers. This year, we're a year later, and the container ecosystem, the container world, is the fastest moving thing in IT. So we're not going to have the same conversation because ops teams now know what containers are. We all grasp what a container is. We talk a little bit about it in there, but really now what we're focusing on today is value. Why should an ops team use a container? And not just because my developer screams that they want to use a container, but how does it make your life better? How does it make your job easier? How does it give you, so we're still very nuts and bolts. There's no roadmap in here. But the conversations I've been having with my customers for the past year are around that. All right, I know what a container is, and I know that someone way up the totem pole is telling me to go do containers, give me some of those things. But how do they make my life easier? So that's what we're focusing on today. Does that sound okay to everybody? Or do we want to get down into the kernel again? We might do both. I mean, hell, who knows? So today's task, and again, OpenShift is the most complete production-ready container platform out there. We're at Red Hat Summit, so it's a pretty friendly audience. You guys voluntarily are in an OpenShift session. So I don't think we're going to, unless there's some Cloud Foundry junkie in the back that wants to start screaming, I think we're okay with that statement. And again, it's all about fundamentals. If you look at OpenShift in action, it's all about fundamental knowledge. It's not feature sets. It's not the greatest, latest new feature. Taking that fundamental knowledge, what is a container? How does a container function inside Linux? How does it take that, when you take that knowledge, then you can start thinking about these things strategically. They're not some weird black box filled with unicorn blood. They're another tool in your toolbox to make your life better, to solve problems inside your data center. And that's what we want to focus on. It's all about the fundamentals. I mean, this guy literally makes container runtimes. We're that fundamental today. There are always a few ground rules. This is a discussion, not a lecture. There are 200 and some people in the room. Don't everyone speak at once. But if you do have a burning question, if you do have something that you vehemently disagree with, if you really just can't not ask that question, feel free. I'd love, if we get to slide 4 and we don't get past slide 4 because we have a great discussion, thumbs up. It was a good day for me. And hopefully we have just a good discussion there. Again, this is nuts and bolts, not roadmaps. And apologies in advance. Again, the fire hose. There's just too much cool stuff to talk about that we're trying to cram it all in. So if I start talking at podcast speed, apologies. If we get to 1.5x, this thing does not want to work. Try it this way. There we go. A little bit about the agenda, how containers work in OpenShift, why ops should care, what makes OpenShift special. There are some pretty distinctive things there. Who should take containers into production? Notice it's not saying who should use containers. Everyone should be using containers. But who matters when they're going to prod? And when and where containers fit. See what I did there with the who, what, when, where, why? Yeah, I thought that was cute when I thought it up at 2 o'clock in the morning. And then with whatever time we have left over, conclusions, QA, call to action, whatever we want to do there. Is that cool with everyone? We good? Nod, head nods. All right. So how containers work. And we talked about this at this session last year. This should look familiar to pretty much everyone if you're using OpenShift. This is deploying a new app on the command line. OC new app. When that happens, when you hit the enter key, when you type that, OpenShift kicks off first and starts doing some things. And I'm waiting for Dan to just start saying, no, you're wrong.
I'll wait till it gets to the node.
Wait till it gets to the fun puff?
Yeah.
Like, did you look? Like you looked. Is there stuff that's wrong? Okay, good. So OpenShift, in this particular case, I'm using S2I to build my application. I get a custom container image built that takes the source code and a base image and marries them together into a custom container image. All that happens in the background, you never see it. OpenShift creates an image stream. Image streams in OpenShift tie all my applications together and lets me do things like automatically trigger application upgrades based on upgrade policies when a new version of my base image is available. So when I do a security update, image streams make my application automatically update itself. A build config. Inside OpenShift, a build config lets me programmatically define how I want my application built. So if I have to do things like if I'm using Java and I have to go in and do things with Maven, God forbid, I can define all of that inside my build config. How do I want my application built? OpenShift also, an object that's unique to OpenShift is the deployment config. Deployment configs dictate how your application gets deployed and updated. So I can say in the deployment config, I want to always have 5 copies running. And when I do an upgrade, whether manually or automatically, I want it to be a rolling upgrade. Or I want it to be a blue-green upgrade. Or I want it to be a canary in a cage. All those different upgrade methodologies. I define them in the deployment config. I actually define programmatically how I want my app to upgrade. So OpenShift can then go do it for me. And that happens in the deployment config. OpenShift also has a routing layer built in. And the routing layer gets updated with the endpoints inside that are your containers. So when you go to the URL, OpenShift knows where to route your traffic to and from. Then OpenShift hands off things to Kubernetes. Everyone knows what Kubernetes is, right? Kubernetes is what's on my shirt here. Do y'all know the Star Trek joke? There's a Star Trek joke in the Kubernetes logo. Have y'all heard it? So in-house Kubernetes, the in-house version of Kubernetes at Google is Borg. Borg are the bad guys in Star Trek. And the most famous Borg was 7 of 9. That was her name. I don't know why she was named 7 of 9. I'm a Star Wars guy. But her name was 7. And there are 7 spokes on the Kubernetes logo, on the wheel for Kubernetes. So there's literally a Star Trek joke cooked into the Kubernetes logo. Makes it really hard because it's not an octagon, and when you go to put the sticker on your laptop, it doesn't fit with all the other octagons. It kind of makes me mad, but it's cute. It's a Star Trek joke. So OpenShift creates all that stuff. Then underneath that, Kubernetes creates a replica set. A replica set is how many pods I want running, how many containers I want to keep running at all times. It also creates a service. A service inside OpenShift lets me use just DNS names to talk to other services. So when I deploy my web front end and I need to talk to my database, all I need to know is the name of my database service. The DNS automatically works, is automatically configured at runtime. All of that just works. I don't have to roll all of that, any of that on my own. There's also a whole bunch of scheduling goodness. What Kubernetes is a scheduler at the end of the day. And also all of that, where am I going to put the next container? Are my containers happy and healthy? Do I have 4? And I really want 5. Let me create another one. Oh, that node's not listening to me anymore. I'm going to blow it away and stand up another one. All of that happens inside Kubernetes. Kubernetes is the beating heart of OpenShift. Kubernetes then hands off to the container runtime. In this example, we're using Cryo. You know a little bit about Cryo.
Yeah. Who here has not heard of Cryo? Okay, so there's a quick description of what it is. So a couple of years ago, Kubernetes was first built totally on top of Docker. And what happened is CoreOS came to Kubernetes and said we wanted to have full support for Rocket inside of it. And so they did a huge patch set for Kubernetes to basically allow it to run Rocket or Docker. And Kubernetes upstream at that point said, no, we can't do this because eventually Garden or some systemd spawn or somebody else is going to come along and want the same type of treatment. So they turned it on its ear, and Kubernetes said, instead of you guys giving us patches, we're going to basically call out to a daemon and say, these are the things I want done. And that's called CRI, Container Runtime Interface. So after that happened, guys on my team said, we could build one of those, and they created it. We ended up being called Cryo, so CRI stands for Container Runtime Interface. O stands for Open Containers. So the real goal of this is to make it as simple as possible for running containers underneath Kubernetes. And it's totally dedicated to Kubernetes. It doesn't work with Mesosphere, it doesn't work with any other type of, Docker Swarm, any other tools. It's just for running containers. And then it launches containers the same way Docker does under the covers, so it ends up launching Run C or other OCI compatible runtimes. It's available as of 3.9, fully supported in OpenShift 3.9. Right now you can either choose between Cryo or Docker to run. We're hoping at 3.10 or 3.11, probably at 3.11, that we will switch it so Cryo will be default for all containers running in OpenShift. And online right now, we're moving all of online to run on top of Cryo.
How big is the Cryo daemon? How big is the Cryo daemon?
Oh, the Cryo daemon is, well, there's two things. The Cryo daemon is much smaller because all it's doing is the implementation of the CRI. It uses up a lot less memory, and we can run all of our containers with, we actually use this thing called C code to run it instead of Go, so it can actually use a lot less memory for running containers than Docker can at this point. So we use a lot less memory and allows us to get greater amount of containers running on a system. So the actual orchestrating tool is not using up as much of the system as the containers are, so you really want more containers on it. So.
Yeah. And there's no root running process.
Right.
Listening. You don't have to be running, your container runtime doesn't have to run as root. Yeah. And for a lot of customers, again, I work in the government, that's a huge stopper. That's a huge pain. Yeah. Having a daemon running as root. That's hard. So we don't have that daemon running that's listening. You don't have to run a daemon to build a container. That's just silly. Yeah. We'll get into that here in a little bit. So Cryo works with Linux to create. So now OpenShift has built all the OpenShift stuff. Kubernetes has built all the Kubernetes stuff. Kubernetes then tells that container runtime, in this case Cryo, to go talk to Linux at this point. Now we're getting down into the Linux, the process isolation stuff. So when we talk about a container is just a process, and Dan's gonna drive this home here in just a couple of minutes. The app you run in your container is your container. What we're doing is taking that app and wrapping it around some isolation, some stuff inside the Linux kernel to make that application feel like it's the only thing running on your server. The same thing we do with the VM, only we're using different parts of the Linux kernel. So they all share one kernel. It's not like a VM where everyone has their own virtualized kernel. That means they're smaller. That means they're faster. Launch times for containers are measured in milliseconds, typically, unless you have a lot of really bad Java code, and I can't fix that. But to launch a container with Cryo, we're talking milliseconds. The RHEL 7 base image, the base container image for RHEL 7, 140 megabytes. Like, how big is your default VM disk right now? 40 gig, 60 gig? To run an app that has, 8K of source code? 140 megs for the RHEL 7 base image to put your application on top of. So we isolate it with three different things. The first thing we isolate the application with are kernel namespaces. The best way I figured out, and maybe you have a better one, to describe what a namespace is inside Linux is that they're essentially paper walls. They're really easy to stand up and tear down. They're very lightweight, but they effectively isolate the things around them. And so the Linux kernel takes your application and puts it in these namespaces. So the mount namespace takes everything that's from that base image that I'm building my application with, my container image, puts it in its own mount namespace. So from the point of view of the application, all it can see is what's in its mount namespace. That's all it can see. So the entire world to that app is what's inside its mount namespace. So we're isolating the file system away that way. The network namespace gives it its own IP address. So every container gets its own IP address, its own MAC address, its own network stack, its own TCP ring buffers, all of that crazy stuff. They're not shared, are they?
Nope.
Yeah, so they're completely namespaced away. So network namespaces, so from the point of view of my app in my container, all I have is that one IP address that I need to talk to. And the Linux kernel isolates it away. Inter-process communication, the IPC namespace, all of our shared memory information. So name semaphore sets, schmal, schmacks, all of those fun things. Things that applications use to communicate directly with one another through RAM. All that's isolated away with the inter-process communication namespace. Dan gave me grief once because I didn't explain it very well and kind of eviscerated me. So Dan, twice, this is my fun rabbit hole, twice in my life, Dan Walsh has completely gutted me with one sentence. I'd been at Red Hat maybe 4 months, and I had to give an SE Linux talk to a group, and Dan was sitting in the second row. And like, I'm not flustered really easily. Like, I like crowds. I like to be on stage and talk and communicate. Telling God about the Bible is a little intimidating, especially when you've been at Red Hat for 4 months and you don't know nothing from nothing. After the talk, I got to drive Dan 30 miles through DC traffic to the place where he was giving a talk the next day. So I get in the car and I'm all puppy dog. I'm like, hey, Dan, how was it, man? How was it? Pretty good? Hey, what'd you think? And he looks at me and all he says with this completely deadpan face was, I've learned not to say anything. I didn't sleep for 4 days. Like, I was gutted. And then, like, years later, I was at a different event, and Dan was there, and I was doing a session, actually the same talk I did last year at Summit, like an earlier version of it. And I was like, I know this thing is good. Like, this talk, I've done this thing like 40 times. I know it's good. And Dan's sitting in the back corner. I'm like, Jesus Christ, all right, here we go. So I do a talk, adrenaline's all running, I'm all talking real loud, podcast speed. And I know I nailed it, man. People were loving it. Walk up to Dan after Dan's walking to his session. I was like, hey, Dan, how was that? Like, it's like vindication. Like, you know, I just proved myself to Dan Walsh. He's like, oh, you're a little shaky about some stuff. I'll talk to you later. And then he walks into a session. And I'm just pacing. Like, I probably walked 3 miles in an hour waiting for Dan to get done with his session so I could address this immediately. Like, I'm not losing 4 more nights of sleep. And so I'm like, all right, what did I not do? Like, I know that was good. It's like, and he starts laughing. He's like, oh, yeah, your explanation of the IPC namespace is a little off. And I aged 3 years in that hour. It was all, so I'm not asking Dan how this goes afterwards. I'm just leaving. So the IPC namespace lets applications have shared memory resources that are isolated to just what's inside the container. The PID namespace, and this is where, when I first started messing with containers, what blew my mind, every container gets its own set of PID counters. So the application that you run to start the container, your app, is PID 1. And I'm an old Linux dude. PID 1's important. The fact that I can have 50 PID 1s on my host and not break the world, like, my mind just exploded. But it works. Again, there's those paper walls inside the Linux kernel that lets that happen. I can actually see the processes from the host on the container, and they have a PID assigned by the kernel, the main PID tree. But from the point of view of the container, the only process IDs it can see are unique to the container, and it's only the other processes running in the container at that time. So I'm isolating it that way. And then I have the UTS namespace that gives each container a unique host name and domain name. And that gets helpful when I've got, 1,500 nodes running thousands and thousands of containers coming and going all the time. So that's how applications feel isolated inside a container. And if that wasn't enough, we actually have 2 more ways we isolate processes inside OpenShift. The Linux kernel itself, and these resources are shared across all containers, create control groups that help me eliminate noisy neighbor syndrome. I can't fix your bad code. Ops guys can't fix bad code as much as we try. But so you can crash your container, but you're not going to crash the whole server. So that's noisy neighbors. It's nice to not have them. And then SE Linux enforces mandatory access control. I used to have this parlor trick that I did. I used to run the hackerspace in Richmond, Virginia. And there was an old laptop running Fedora, and you had a root prompt sitting there. And I'd given the root user a funky SE Linux context that didn't let it do anything. So even though you were UID 0, you couldn't write to /temp. And I taped a $100 bill to the top of the laptop. I said, if you can do anything on this system, from here, from a root terminal, $100 is yours. And 6 months later, I bought everybody pizza with the $100. SE Linux, do you want to dig into SE Linux at all? You know a little about it.
Yeah. So, I like to talk about SE Linux and containers as like peanut butter and jelly. So if you look at containers, right, containers are using all these namespaces to give you that virtualization feel, isolation. And then the problem with the namespaces is if you're running a privileged process inside of the container, you can reverse the namespaces, right? You can potentially mount content. You can do all sorts of stuff. but we take advantage of things like all Linux capabilities and lots of other security features, but none of the security features protect the host file system. So the two ways, Docker is, people have broken out of Docker twice with CVEs. The first one was, it turns out the slash is an easily guessable inode, and there's a function call into the Linux kernel called openfileat. So you can actually say, on this file system, open this inode without going down paths or anything else. You can actually do that if you're a privileged process. So Docker had that vulnerability. So if you opened up slash, now you could start listing slash and walk your way down. Well, SE Linux instantaneously blocked that because a container can only use container types. So a container T can only read container file T. The second breakout was lots of people, if you ever played with containers, when you have a running container and all of a sudden you exec a process into the container, you do a Docker exec or a runc exec or podman exec, you can stick a process into a container that's already running. And the problem there is when you stick the process in, it comes with open file descriptors. So if you had a process that had an open file on the host operating system and you execed it into a container, the process inside of the container can now attack your process, get access to those open file descriptors, and then walk the file system. And again, SE Linux is the only tool that breaks that. So SE Linux and containers is critical. So I know everybody out here always has set enforce one.
Everyone's running in enforcing mode, right? Raise your hand.
No, we don't need that picture.
Everyone raise your No, seriously, everyone raise your hand.
So, but
like,
when
the only way I'm sleeping tonight.
When you move to containers and you move to, actually if you're running virtualization, you should always use SE Linux for at least those two use cases. So SE Linux really protects containers from container breakout, basically.
In OpenShift, SE Linux is enforcing by default, and the install won't happen if it's not. You have to run SE Linux in enforcing mode in OpenShift. You have to go out of your way to turn it off. And then I think we turn the screen red and like skull and crossbones and scream at you before we let you do it then. All right, so that is a modern container application platform. That's how the processes are isolated. That's who handles what. That's how OpenShift works at a high level. Does that make sense to everybody? No unicorn blood, no magic voodoo, no spells or hoodoo bags, nothing from season 8 of Supernatural. That's how containers work. That's how OpenShift works. So why do you care? And this is where we start talking about value. I'm an old ops guy. Y'all are all ops folk. We have two masters that we serve in the operations world. One of them is not the dev team. Remember, we're all DevOps now, right? So it's all kumbaya and 12-string guitars. We love each other. You can argue with the dev guys, but at the end of the day, we're not always beholden to them. We work with them, but we don't serve them. But ops teams do serve two masters. Raise your hand if your budget is bigger next year than this year. Yeah, that's master number one. None of us have big budgets. None of us have growing budgets. We always have to do more with less. That's our world. That's what we do. And number two, we work with the devs. We're beholden to security. The security team can stop everything we do. And that's just the life we live in. So why should you care about containers? Because containers and OpenShift help you solve both of those problems more efficiently and more effectively. That's why you have to care. That's the discussion I've been having with every customer I talk to for the past year. Also notice the rockstar status of the ops guy. I just want to point that out. Last year, that picture was a bald guy with a big beard, and it hit a little too close to home. So this year, I made him a rock star. I don't know how to play guitar. OpenShift and containers help accomplish both of these tasks better. I'm not saying you're not doing it now, but it's better. So first, more with less. And containers, I always talk about them being an evolution. We're all hung on this timeline of evolution, and that evolution is about process isolation. We've been isolating processes since we've had processes to isolate. So we have two axes here. Going to the right, we have abstraction and automatability, which is good. And on the bottom, going right to left, we have size and power consumed. And it all started with ENIAC, or whatever you want to call the first computer, where we had to physically go flip switches to write ones and zeros into memory registers. We could run one process at a time, and it was the definition of unautomated. We had to go flip switches. Then we got mainframes. With mainframes came time sharing. Multiple people could log in at the same time. Multiple people could run applications at the same time. They're still pretty big. There's one out on the expo floor. It will not fit in the trunk of my rental. But mainframes are good, and mainframes are still around. We have thousands of mainframe customers at Red Hat, and sometimes it does a really good job. The IRS, they're one of the customers I work with, they have a mainframe application that's been in constant production use for 57 years. We got IRS guys in the back. Or did you just get a giant tax return? Either one. So from mainframes came the client-server model, pizza boxes, where I could go hug my server. So the size of my computer is getting smaller. The power consumed is getting smaller. Still not abstracting very much. I'm still not automating. I can go hug my database at this point still. That means new project equals new server, equals new power, equals new cooling, equals new networking, equals new cables. Still not automating at this point. I can't, unless I really want to go nuts and have a robot in my data center that can rack servers for me. Then we got VMs, and this is where most of us live most of our lives, right? We're not 100% containerized, but we're not running on mainframes for everything. Virtual machines, VMs. I can't go hug my database server anymore, but I can right-click and deploy one. I don't have to go rack a new server every time I want a new server. I just need to have enough resources that are racked to give me a new server. So now my abstraction, I've abstracted away my server into a virtual thing that lives inside the Linux kernel, at least with KVM. I'm able to automate that because I'm able to talk to an API. I can use things like Ansible to automate the creation and the management and the destruction of my virtual machines. But I'm still too big. Like we said earlier, your disk, your default disk in a VM is probably 40 or 60 gigabytes. And the source code for the application running on it is probably 4 megabytes. Very small applications, but every time I need a new one, I have to virtualize an entire hardware stack. I have to virtualize an entire kernel. I have to then have all of the file system and all of the things that the Linux kernel needs to keep itself alive. I have to have an entire root file system every time I need a new VM. And that's just not as efficient as it can be. It's more efficient than mainframes, sure, but it's not as efficient as it can be. The latest and greatest evolutionary step is containers. Now I have one kernel running, and I'm using the isolation, the ways to isolate the process we just talked about. Now I can have one kernel and multiple isolated processes on a host. So on my physical server, I'm running multiple virtual servers, and on my virtual server, I'm running multiple containers. I'm consuming less power for each one, and containers are more automatable, they're more abstractable.
Yeah, I have a question for everybody in the room. Do you guys run computers for operating systems? Or do you run them from applications? You run them for applications, right?
It's a great way to
put it. So the first 4 boxes there are all operating systems. And I think you should run them for operating systems because that's where I make my money. But the big change here is that since the first 4 boxes are all about managing an operating system, the 5th one, containers are really about managing individual applications. We call them containers, but what you have in there is a single application, usually inside of a container. So the prescribed way to do this is to have a single, a web service application or a database application or something. So you end up in a container world, you're managing applications instead of managing virtual machines or physical machines or all the way down the stack. So always think that containers is not anything special other than you're really looking at the application. The only thing that goes inside of a container image is your application.
Yeah. On this slide, I was going to put like an I started here at the virtual machine thing. Like my IT career started like RHEL 5.2, and Zen was there, so we used a lot of Zen. And then I was going to put an arrow to where Dan started.
Yeah, I'm back at ENIAC.
Exactly. Like Dan's like 3 feet off the screen is what I was going to do. But I decided not to be that mean and just talk about it instead of actually do it. So that's how we do more with less with containers. I'm able to abstract more, and I'm able to make my application scalable unit significantly smaller, which means, in essence, I just grew data center. I can run more application per U, more application per square foot, more application per watt. So applications, containers equal money. I can do more with less with containers. So how does it help with the security story? You doing a clicky?
So we're going to do a quick segue where I get to preach for 5 minutes here.
We're all about to go to church.
So a lot of times, you know, when I talk to people, they're always worried, obviously, about security. And matter of fact, upstairs, I've been talking all week to different customers about security. And I have a few key features that I think you should think about. First of all, containers are just regular processes on a system. So one of the, you know, we talked about those namespaces and stuff like that. But if you booted up a RHEL system right now, and you looked at the first process in the system, PID1, System D, running on the system, you could actually go to proc1 ns, and you would see that System D is running in a bunch of namespaces. Secondly, if you looked at SC Linux, you do ps-ez, you'd see that System D is running with SC Linux label associated with it. If you went and catted out proc1/C groups, you would notice that System D is running in a bunch of C groups. So you could argue if a container is something that runs in C groups, has security controls like SC Linux wrapped around it, and has namespaces, it's a container. So there's a t-shirt that I think it's downstairs, and probably someone in this room has it. We say containers is Linux and Linux is containers. That's what it means. Every process on the system is wrapped by these three things. Container runtimes like Cryo and Docker are just going into the kernel and modifying those a little bit. And the bottom line, though, is another question that's often asked is, can I do this inside of a container? Because people think containers, they think VMs. They're not VMs. They're just regular processes in the system. So if you can do it on Linux, you can do it in a container. And it's all a matter of how much security and how much you're going to tighten down the security. But you can do anything inside of containers. So compliance, he asked about compliance here. Compliance on the host applies to container processes. So if your RHEL system is certified, you know, any government and people in here, if we have a certification, EALP or LSPP, things like that, these are regular processes. There's nothing in containers to make them not compliant with the standard RHEL compliances. So any type of compliances, you have it. So the next article, I advanced to 2 here by mistake, but my biggest sadness about containers up to this point is this thought about root. Okay? When you guys, anybody that plays with OpenShift, what's the one thing that aggravates you? The one thing that aggravates is you want to run all the stuff from Docker.io. The problem is all the stuff at Docker.io is built wrong. It all assumes that you have to be root to start up. So I wrote an article on opensource.com telling you just say no to root. Can you name an application you want to run in a container that requires root? Almost nothing. Databases don't require root. Apache doesn't require root. Nginx does not require root. Just about nothing that you run on your Linux system that doesn't manage the operating system needs to be root. So why are all these containers built with requiring root? All right, there's 2 reasons for that. One reason is they want to bind to ports in less than 1024. If you went back to 1968, when Unix systems were first coming on, there were 6 computers in the world. Okay, and if you could bind to a port in less than 1024, you were trusted. That meant you were an admin. If you're bound to ports greater than 1024, that meant you were a student at a university or a military base or whatever. And so that was where that was a security concern. But Unix and Linux have never changed. So we still have the rule that you can't bind to ports in less than 1024. So that's why Apache binding to port 80 requires root. If you're running in containers, we can actually set it up so Apache can run inside of your container and listen on port 80 without requiring root, because the container runtimes can actually configure that. The second reason we can have to run our containers as root is because we're building them from packages like RPM or Debian packages. Those packages come with the assumption that they're going to be installed on a physical machine or a virtual machine. So they come in with the assumption that they're going to be installed and started as root and then drop privileges. So whose fault there? It's Red Hat's fault. It's my fault, Fedora's fault, Debian's fault, Ubuntu's fault. We've all put software like Apache, way it's packaged now, it comes in assuming that it's being installed as root. And when we packaged all that stuff up into containers, we went with that forward. So what you need to do, if you're going to have your developers come into you and say, I need root, they're all going to say, I need root, and you're going to say, no, you don't. What are you running inside of the application? What thing in root do you need? And if we could just make that assumption, make that switch so that you weren't running your software in root, all of a sudden security concerns go down to basically time-sharing type systems. You know, the security that we have for different users, if you can just run these things as not root.
You forgot laziness.
By the way, OpenShift default can't run it as root. Okay, and that's what people complain about. Yeah. And then we add all the other security goodness around it. But if you just start with the assumption that you're a non-privileged process running an Apache web server or anything else, then you've instantaneously skyrocketed the security. FIPS mode, that's another compliance thing. How many people in here care about FIPS mode? Okay, so there's a handful here. FIPS mode, for those that don't know, is basically a rule in the Linux kernel that says that there's certain algorithms, crypto algorithms that you can't use, or certain crypto algorithms you can use, and they define it. And basically, in a FIPS mode system, the libraries, SSL libraries, things like that, are controlled, basically drop algorithms if the machine is booted in FIPS mode. Turns out containers don't follow FIPS mode. All right, if you're running Docker containers that come from random distributions or random packages, you can't have FIPS mode because the libraries don't understand it. They don't understand it boots up. So we're actually working to get FIPS mode fully compatible in our container runtimes, like Cryo, now support FIPS mode for at least the container runtimes. There's a little problem, though, is that Go language, which all the cool kids now code in, doesn't currently support FIPS mode, but Red Hat tooling people are working to get
that patch went upstream last week.
Well, the problem is it's probably 6 months to a year away from RHEL.
So you know, I'm in sales. Patch went upstream last week.
Yeah. So Golang is so hopefully once we ship a Golang package, then we can go full FIPS mode on the machines. Another problem with the way Docker has trained us all to run containers is they combine two things together. They combine building containers and running containers in production. Because of that, we made the assumption that containers have to be able to modify themselves. So if you're running your application and you're running your web service in production, do you want the web service to be able to modify /user? Okay, and that's what most people, when they run containers, almost 90% of the people running containers right now are running them in such a way that they can modify their own executables. We're not covering that up with anything like SC Linux or anything else. But I believe containers should run in read-only mode. One of the things we're going to do with Cryo is we've added a flag that basically forces all containers that run in production to be read-only. That means that they can only write to directories that are giving to them to be read-writable. But basically, their entire /user becomes read-only. Not yet. Be 3.10. Container images should be minimal. This one seems obvious. And when I'm talking about minimal here, I'm not talking about the Alpine versus RHEL thing, which is all about size, and really is a developer concern because he wants to pull down small number of bytes. When I'm talking minimal here, I'm saying we have a whole bunch of cruft that goes into container images that can be used by hostile people. So every container image you get has Bash in it, has Python in it. You can install additional packages. Because they're read-writable, if I hack your system, I can actually DNF install inside of your container. Okay? Yes? So container technology only runs on RHEL 7, but you can package up RHEL 6 content and run it on a RHEL 7.
So the question was, is there a RHEL 6 container? Is that correct?
There's a RHEL 6 image that can be run on a RHEL 7 system.
To run a container, you have to have RHEL 7 as the host, but then I actually know customers that have built RHEL 4 container images that work.
So we built a new, so Docker build basically has the assumption that you have everything inside of the container required to build it. To me, this is like saying I built a C program and I have to include make and GCC and everything else has to go with the executable. I think it's wrong. I think what you need inside the container is just the tools that are required to run the container, run your application. So if you're running Apache, the only thing that should be in there is the Apache process, Apache code. With the Builder tool, which we also introduced 1.0 this week, you can actually build minimal-sized container images. These things can be stored at Docker I/O or any other container runtime, and all the tools can run them. But what we do is instead of making the assumption inside of the container image that you have yum and all that stuff in it, we pull that all out. So the build host has all those tools, and then you just redirect your output into the container image. So only need content needed for the application. Take a look at Builder. Replace the image, don't yum update. How many people have gone into a container and done yum update? All right? A lot of people have done that, right? Matter of fact, you admins are basically advised to do that because you go onto a VM and you update when the security fixes come out. So why not go into a container and run yum update? And of course, Docker build forces you to have yum inside the container, or DNF inside of the container, or apt-get inside the container. Well, if we want to do microservices, the way it's supposed to be, these are supposed to be read-only images that you replace. So if I have a version of my application running and I find out a vulnerability, what I do is I create a whole new image with the same executable in it with the fixes in, and I replace it. I don't go into the image and update the image. Okay, I replace the image. These are just, think of them all. Everything is read-only images, and I'm build. So I go through my build chain to build new applications. Okay, last statement. Physical machines, he actually showed in his display, physical machines versus virtual machines versus containers. And when it comes to security, the most secure way, if you want to run, you're running 2 apps in the world, most secure way to run 2 apps, 2 physical machines. The more isolated they can be, the better. Put one on the moon, one on the earth. If that's, and that way, if the earth explodes, you'll still have your service up and running, right? But the further away is, and that's anybody in the military talks about, air-gapped. Well, when they're talking about air-gapped, they don't even want a network between them. Okay, that's best isolation. So obviously that's too expensive. So I go from physical machines to virtual machines. So virtual machines, great security, right? There's been very few breakouts of virtual machines. In one of my coloring books, I talk about this as being sort of like a duplex house where you have, a separated isolation, but you share a common wall between them. Containers are like an apartment building. They have a single point of failure. Okay, that means that if I take over the host kernel, I can take over the system. And that's the real fear of containers. That makes it sound like containers are bad, though, because the next level down is when I have 2 services running on the same machine at the same time. If one of them gets hacked, it's really easy. If I put those 2 applications instead of running them 2 on the same server, I put them in containers, instantaneously I've skyrocketed the amount of security. So physical machines, more secure. Virtual machines, next most secure. Containers, next most secure. And then running physical. But the key factor here is not a zero-sum game. You can use all these technologies together. If you have your apps with your database and my credit card data stored in the system, put it on a separate physical machine, inside of a separate virtual machine, behind a firewall, and then run it inside of containers. All in that stack. The front ends go into DMZ. They're running on separate physical machines, separate virtual machines, separate containers, and isolate them based on the security roles of each one of those. I think that's done. My preaching is over.
Yeah.
Yes.
Dan Walsh just took us to church.
Are there any advanced networks in your group, things like MacBLAN, UK, anything like that, where you're not running HTTP microservices, advanced network?
I can't think of one.
Yeah.
You could probably come up with a corner case if we stopped and dove on it.
Things like NFV, we do use very unusual networking.
Right, but I mean, basically any network device can be stuck inside of a container because containers are processed on Linux. If it runs on Linux.
The root, like DK or MacBLAN or
Yeah.
they can all be run with no root.
Right. Well, I don't know about, well, they could be run with using namespace implementation of a fake.
Yeah,
root,
let's
yes.
parking lot that one over. We only got about 8 minutes left. It's an interesting thought. Let's talk about it here in about 8 minutes.
Yeah.
So who should use containers isn't the right question. We should all use containers. Who should take containers into production? When the data matters, who should be in charge of the data? And the answer is us, the ops guys, the ops team. We're the people that have the security posture. We're the people that have the compliance posture. We're not the devs. The container revolution did start on developer laptops, so it's kind of skewed that way, that idea of a full stack developer. You can't know all of that. It's impossible. You have to separate those concerns. Inside OpenShift with Kubernetes, those concerns are actually programmatically in there. They're defined. There's a separation of concerns inside OpenShift. So there is a control plane that the ops team handles. And that control plane is cluster-wide options, how to attach to storage, which storage to attach to, project-wide resource limits, project-wide quotas, role-based access control. All of that is completely the purview of the ops team by design with Kubernetes and OpenShift. And then there's a data plane, and that's the actual running containers. And that's where the developers live. That's where all of that stuff gets deployed to. But the infrastructure that they're controlled by is managed by the ops team. Kubernetes and OpenShift is an ops tool. Containers are an ops concept. They just exploded, the marketing exploded on developer laptops. We have to implement this stuff, which means we have to know how it works. Examples, you say? Looking at storage. We actually divide storage into two things. When the developer writes the application and they write the deployment code for OpenShift, they create a persistent volume claim in the application, which is a request for storage. That persistent volume claim says, I need 10 gigs of storage. I need it to be read-write mini. It has an access mode. Different storage providers, different storage backends have different ways to provide storage. And then I can define a storage class. So I could have database storage, or I could have production storage, or dev storage. And that's built into the application definition in OpenShift. That's the data plane. The control plane is the persistent volume. That represents, inside OpenShift, the storage itself, a mountable storage volume. Dan's phone's going off. That was a weird ringtone, dude.
That's an alarm.
Oh, it's an alarm? You have 5 minutes. So a persistent volume is what the ops team controls. So what this looks like, inside OpenShift, we create persistent volumes that are of different sizes and different classes and different access modes, and they're requested by applications when the applications are launched. What happens in the real world is you have, in this example, I have an NFS storage system. I have an NFS export. That NFS export is mounted by OpenShift onto the right host where the application is running. So OpenShift knows I'm going to put it on this host, and I'm going to take this NFS mount or this Gluster mount or this Elastic Block storage from Amazon. OpenShift actually supports 13 different storage backends out of the box, and then there are other third-party ones beyond that. So I'm going to take it and mount it, and I'm going to mount it into some random path down var lib. Holy crap, I can't remember all these hashes. And then I take to the container, so I have my exported NFS volume, I have it's mounted by OpenShift, so it's not actually mounted by the devs. Inside the container, it's a bind mount. And a bind mount is a kernel trick where I can take a volume in one place and simultaneously mount it in another location. So I can bind mount it into my container's mount namespace, but to the application, it just looks like a directory. So the application doesn't have to know what type of storage it is. It doesn't have to know that it's an FS. It doesn't have to know that it's Gluster. It doesn't have to know that it's Azure. It doesn't have to know that it's Amazon. So I can abstract away all of that in the data plane. It's just a request for storage. How much do you need? What kind do you need? And the ops team takes care of the rest. And there are 400 different ways to solve that problem. But OpenShift is, everything is divided that way. Everything is control plane, data plane. And that's how that all works. So when and where to use containers, and we're running real low on time, so I'm going to blast through this last one. I found this picture just last week. Containers go everywhere. HPC, big data, government, financial, animation. Had a 3-hour conversation this week with someone actually running containers to do animation renderings in their render farm. Goes everywhere. The link to that picture, it's actually off the Kubernetes blog. It's pretty awesome stuff. And then conclusions and QA, and we only have a few minutes, so not a whole ton of QA. Apologies for that. I think the sermon was worth it. Containers are the next evolutionary step in how we deliver IT. I guarantee you there is some kid sitting at MIT or Butte County Community College thinking up the thing after containers. It's an evolution. It's not an end game. There will be a better way to isolate a process than a container. I can't fathom what it is, but it will happen. We couldn't fathom containers, so someone decided to put them together that way. They aren't going anywhere. These are not a fad. This is how we're going to deliver IT for the next 5 to 7 years. Get used to them. There is no monopoly on how to make or manage them, but OpenShift is the best way to do all of that. A little bias again. So apologies for running right up to the end. Dan's new coloring books, Do you have any of the new ones left? Because I need one.
I'll get you one.
Okay, awesome. So we have Container Commandos, and then the original edition, Three Little Pigs. And that's what we've got. Thank you guys for coming in.